Welcome back. So we're going to continue our investigation on exponential growth and decay. However, we're going to talk about a very specific case. We're going to talk about compounding interest in this next section. So compounding interest occurs when you give your money to a bank and you're accumulating interest that is compounded so many times per year. So the formula may look sort of familiar. Your P right here, that is talking about how much money you hand the bank. R is the rate. T is obviously how long you leave it there. Now the new variable, that N is the number of times it's compounded in a year. Okay? So number of times it's compounded each year. So annually would mean it's compounded once per year. So you'd use a 1 for N. Semi-annually would be 2. Quarterly would be 4. Monthly, 12. Daily, 365. So it's just the number of times it's compounded in a year span. But otherwise, it's exactly the same as what you've done before. So we're going to identify P, N, R, and T. We can type it in the calculator all at once, making sure we use parentheses properly. So parentheses around the 1 plus R over N, and parentheses around the N times T. And for monetary values, since we're always talking about money, make sure you go to 2 decimal places. All right, so let's jump right in and start using this formula. So an amount of 1,500. All right, so that's going to be our P. Our P is at 1,500. Deposit in a bank using an annual interest rate of 4.3%. So our R is 4.3%. But again, as a decimal, we move it over twice. We get 0.043. We're talking about 6 years. And our N is talking about being compounded quarterly. Well, being compounded quarterly, remember there's 4 quarters in a year. So my N is going to be 4. So again, the first thing I'm going to do for all of these is I'm going to label those out. And now I'm ready to plug everything in. So I'm sorry, I forgot my starting value. 1,500, 1 plus 0.043, or being compounded quarterly, and then to the power of 4 times 6. Now, you can type this in all at once if you're careful and you use parentheses. So if you put these in parentheses, awesome. Now what I might even recommend, just to make that part a little bit easier, is just call that 24. All right? Get a single number for your exponent just to make it easier for you, but you can actually type that whole thing in to the calculator. All right? So let's take a look at what we get. So we're going to type in 1,500, 1 plus 0.043 divided by 4. Again, you can type it in just like that. And then to the 24th power. So if you're using a single exponent, you can type the whole thing in at one time to get your value. And you get $1,938.84. So 1,938 and 84 cents. That's going to be the money you would have after 6 years. And again, the neat thing is you can type the whole thing in all at once. All right. So for our next example, that same money is deposited into the bank, paying an interest rate of 4.3%, but this time is compounded monthly. Okay, so we have all the same information. Our P, our initial amount, is still 1,500. The rate is still 4.3%, which you know as a decimal is 0.043. We're still talking about 6 years, but this time is compounded monthly. So this time we have an N of 12. So that's going to change my formula a little bit. So I'm going to have my 1,500, then 1 plus 0.043, this time divided by 12 to the power of 6 times 12. All right, now again, I would take care of that exponent first. So I would take 6 times 12, type them into the calculator, and I would just get that to be 72. Because now this can all be typed in at once. So I can have my 1,500 times 1 plus 0.043, now divided by 12 to the 72nd power. So I'm going to get $1,940.61. Now, everything was the same except for that N. Okay, my N went from quarterly up to monthly. And I want you to notice what that did to my value. Notice I ended up making more money. The more something is compounded, the more money you end up making in the long run. Okay, so that's an important thing to realize. The more money you make, or the more it's compounded, the more money that you're going to end up making. All right. Suppose you invest $500 in a savings account that pays 3.5% compounded annually. How much will there be in 5 years? Well, we're starting with $500, a rate of 3.5%. But again, we need to know to turn that into a decimal. So that's going to be 0.035 as a decimal. 5 years, so my T is 5. And compounded annually, well, compounded annually is going to mean my N is 1. That means once a year. So let's plug all of that in. 1 plus R over N, N times T. And again, I would just get a single number for my exponent. So I would take 1 times 5, and I would just call that 5. All right, so let's take a look at this. I'm going to plug this into my calculator. So 501 plus 0.035 divided by 1 to the 5th power. That's going to be $593.84 that I would make after those 5 years. All right, now an interesting question. How long would it take to have $700 in that account? Well, that's an interesting question. So the strategy for this is if we want to know the end result, we want to know how long it'll take to get up to 700, the best way to do this would actually be to make a table. Okay, for times and then amounts. Now what I want you to see is when my t was 5, when I was 5 years down the road, that was $593.84. So if I want $700, clearly I'm going to have to try higher values. So let's try some higher values, shall we? So if I know I need to be more than 5 years, let's try 8 years. So now I'm going to use that same formula, okay? That exact same formula, but this time I'm going to plug in 8. Oh, I'm sorry. I'm going to plug in 8 instead of 5. All right, so I have $658.40. So I'm still not up to that 700, but I'm getting close. So let's try 9. So I'm going to go back to my calculator, and now I'm going to plug in 9 and see what I get. Okay, well, I'm getting closer, $681.45, but I'm still not quite to that 700. Let's try 10 years. So 500, 1 plus 0.035 to the 10. Oh, there we go. I finally reached over $700. So after 10 years, I will finally reach my goal. So I'll have $705.30. So the answer, after 10 years, I will be able to do that. But again, when you're looking for how long it'll take to get to a certain amount, you need to make sure to remember to make a table to try values until you reach the amount that you're looking for. All right, so this got to be a little bit longer. I apologize. But again, thank you so much for joining me. And please make sure you come and ask if you have any questions.